Terrence Howard has some amazing claims. He has an amazing theory, and it's gone viral. He was on Joe Rogan to explain it. I've been letting it sink in, and now Eric Weinstein went on Joe Rogan with Terrence Howard and gave him what Weinstein calls an elite review. So not a peer review, but an elite review. And Weinstein said, kind of blustery, that a lot of Terrence Howard's arguments were bunk or BS, actually. But he did say that the Lynchpin is a very important and could be critical discovery. And the Lynchpin is literally the linchpin of Howard's whole claims. So if Weinstein is saying mathematically the Lynchpin argument could be correct, the Lynchpin is the basis for the whole scalar fractal theory that Howard is proposing. If the Lynchpin is correct and could be this scalar fractal beginning, then it means that Terrence Howard's arguments could all be correct. So this could be the literal linchpin of Howard's arguments. That's why he called it the Lynchpin. He said his wife would say that's the thing he'll be remembered for. A lot of people have been asking for a reaction video to Terrence Howard's claims. I've been looking into them, trying to understand them. And after this final Eric Weinstein, Joe Rogan interview, I think I do understand. And yeah, it is some mind-blowing similarities. For this video, just going to explain first how Eric Weinstein actually thinks the argument is correct, what the Lynchpin is. And then following that, I'll show some similarities between the theory I've been proposing over the last 2+ years. Thanks for being here. Chris Lehto, welcome to Lehto Files.
Can you bring us a Lynchpin?
Bing, 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 bing.
Okay.
Howard's Lynchpin. Howard's extraordinary claims for the Lynchpin appear to mirror Green's extraordinary claims for the string.
So let's look at Terrence Howard filling up the dead air here, talking about the Lynchpin.
Okay.
The Lynchpin is the lowest common denominator of all matter, either seen or unseen. The Lynchpin is the internal dimensions of a torus. The Lynchpin is the universal wave conjugator for all things matter. It is the true currency of the universal flow because it is the common factor of all things. It is the smallest, it is the measurable constitution of a quantum or quanta, the smallest reflection, ultimately in collective potential of all things, which equals the multiverse, blah, blah, blah. Let's now just watch our friend Brian Greene do the same thing. Great expression on Friday's face.
String.
Okay, so that was a great, if kind of ironic or humorous discussion of the Lynchpin. What he shows here is Brian Greene explaining string theory. And he uses all these same kind of miraculous terms, explains the whole universe, little tiny strings, magic. Okay, string theory, especially lately, has been shown to just not be correct. Okay, they found nothing. They found no strings. Okay, Weinstein brings this up, but then says, your Lynchpin idea actually does have some merit with the geometry. So what is the actual argument? Okay, so this is the first interview between Howard and Joe Rogan. And that is actually a 3D model of a Lynchpin. He's going to talk about it here. This is the most replayed part of the video from his first interview.
It's based upon their lack of understanding. Because they don't know how the universe truly works, because their math has been off for so long, because their fundamentals are wrong, now everything has this expiration and there's a loss to everything when the universe is perfectly balanced, when you utilize it properly. And that's why I wanted to introduce the wave conjugations and the mirror shapes and all of these things, defining the electric field, defining the magnetic field, and the constitution between them being the Lynchpin. Because the Lynchpin, as you'll see in a second, it has that same center as that tetryon space. The magnetic field, the feminine side, all of this is circular. That's the full expansion. This is the common factor or the constitution between the micro and the macro.
Okay, so now I fully understand this. This is just a mind-blowing concept, right? So you see right here is a little pyramid, okay? And that is a tetrahedron. That is a pyramid. And that's what he's saying there is tetrahedron. And when Eric Weinstein's talking about the 109.47 degrees, we'll get into that a little bit later, about the sound. He's talking about the angles of this tetrahedron. space. Okay, so it's like a geometry discussion. But so what Terrence is arguing is that you have a scalar fractal nature to the universe. It is between electric and magnetic fields. So this is what I argued, is that light is made up of electric and magnetic, which is really a plus and a minus, order or disorder, however you want to consider it. Howard calls it a contraction and an expansion force. So one of them is contracting, the other one is expanding. And when he says conjugation, what he's talking about is this is like the start, okay? And then from here, it fractals out. So this is like the beginning of the fractal pattern. And on the Eric Weinstein, Howard, Joe Rogan interview, that's what they talk about at the beginning. They talk about this flower of life, this ancient design, okay, that starts with center geometry, and then it fractals out through fractal math, essentially. So in mathematics, a fractal is a geometric shape containing detailed structure at arbitrarily small scales, so it can just continue, usually having a fractal dimension strictly exceeding the topological dimension. Many fractals appear similar at various scales. Okay, so they're basically scale invariant, as illustrated in successive magnifications of the Mandelbrot set. This exhibition of similar patterns at increasingly smaller scales is called self-similarity, also known as expanding symmetry or unfolding symmetry. One way that fractals are different from finite geometric figures is how they scale. Doubling the edge lengths of a filled polygon multiplies its area by 4, which is 2, the ratio of the new to the old side length, raised to the power of 2, the conventional dimension of the filled polygon. So this is the Mandelbrot set. And what notice here is this is a wave conjugation, I believe he's referring to, is you start with one little simple geometric shape. And then once you expand it out, okay, the math is going to work that it's going to forever fractal. So this is what he's talking about, different scales, scale invariance, based on just magnetic and electric fields. And that's what he says how they're killing gravity, is it's just based on the magnetic and electric fields. Okay, so what he's going to show here is now if you scale it, right, using this geometric shape, which he argues is the basis of a hydrogen and a proton, I believe he says a hydrogen, so which is a proton. If you expand that out, so use fractal math basically to continue the pattern, now you will be able to create larger structures. You'll be able to predict physics of larger structures. So this is this scale invariance where you're going to have different math at different scales, but it all comes from the same basic conjugation. There's another way that they describe it, right? So if you carve out the spheres, right? Imagine electric energy's here, magnetic, this is the vacuum, he calls it, basically the lack of the negative space. That's that tetrahedron. So now if you scale it out, now you have multiple tetrahedrons matched together. So this is the 6 he's talking about. So your first is 3, essentially. And now it combines to 6. Now it's going to form a new shape, right? It's going to scale out. So that's the scale conjugation. And so it's going to keep scaling into these new shapes, just like fractals, right? So what Howard is arguing is you can continue that. And he argues that he was able to design Saturn, predict it essentially with a physics engine, just scaling the fractal pattern. He explains it here.
That's what the Lynchpin was. And that's what we're about to see in the video. Was it able to come up, Jamie?
All right, here we go.
And this is rebuilding the planet Saturn. Go ahead.
I have 2 groups of vortexes, which are just like tornadoes, spinning tornadoes that are pointing towards the center. As I highlight this object here, you see that yellow line, right? So there's a bunch of those in there. There's actually 16 of them, and I'll highlight them all. Yeah. You can read it out so you can kind of see it a little bit better. So they're all pointed towards the center, but they're arranged in what we call the Lynchpin configuration. I'm going to pretend like you never heard of that. So there's one on the top and then 3 in groups of 3 around that are spaced at 120 degrees apart. And the tilt of these ones on the bottom here is 109.5 degrees. The relationship to the top ones that are creating this flat space on the top and the bottom. And they're spaced at 120 degrees radially. And then inside the model is 3 groups up to 1,000 pounds, from 2.2 pounds to 1,000 pounds. And there's no gravity whatsoever in this model. There's no center attractor. So it's just vortexes and two magnetic fields, a north and a south polarity, and 1 harmonic resonance, which is emanating a vibration in the field.
Okay, I'll stop it here. So he basically described the setup. So basically he said, and I haven't looked at the detailed model of this. I'm curious to see more advanced models on this. According to this, he basically put in the Lynchpin design, and he added 2 magnetic fields, right? A plus and a minus, so a north and a south. And then he added a little bit of vibration at the base. And he called that a harmonic oscillation, right? So some sort of little bump, because he said that causes everything to bounce into each other. So I don't know if that would change it. Could you just change all the numbers to get a Saturn to pop out of this? But according to that, without any use of gravity, just magnetic and electric fields and the actual geometric structure that Howard is proposing, he's able to create Saturn with the rings and miraculously also the hexagon up at the top.
In this region here where these vortexes are pointed, so it kind of just oscillates to give it a little bit of randomness in motion so that the particles will kind of interact and bounce around like smoke or water, waves and water. And then when I hit play, it does it all by itself using physics simulations. So there's no animations at all in this model. And when I play it, this is what pops out.
Holy fuck.
Wow.
And then when I look down at the top, it makes the actual hexagon that NASA has observed on the top of Saturn.
Okay, pause it here. So that is just mind-blowing. Not only does it make the rings, but it also creates these crazy hexagonal shapes on the pole of Saturn, which is also on Jupiter. They have polygonal shapes on Jupiter as well. Okay, so look, the actual image, 2016. And that's where you see a hexagonal shape, which is insane. And you've seen in Jupiter also crazy hexagonal shapes. So they don't know why this is. Right now, they believe it has something to do with a standing wave. Howard, using his physics engine and just conjugating up from a simple geometric design and actual simple rules, according to that physics model, was able to create Saturn, which means he was able to predict using simple rules and a simple geometric setup using scalar fractal math, essentially fractal geometry. He was able to predict much larger phenomena, an incredibly different scale, which is just miraculous, right? This could prove Howard's theory correct. If the Lynchpin is correct and you can actually use it to predict real phenomena, then that would explain this shape. You could explain the shape, right? Which is not known with our current understanding of physics. Like, why does that happen? They're still not sure. But if you can explain it with a ground up physics model, then chances are it could be correct. Eric Weinstein says the Lynchpin is the most correct part of his theory, which is just amazing. So my mind was effectively blown and continues to be blown by just amazing similarities. It seems like Howard's theory started from the bottom and went up. But my theory I proposed a year ago, I started at the largest scales and went down. And I was missing some key parts. And really, Howard's theory filled in some really big sections of my theory. And so the rest of this will just be going through similarities between the two theories. And if Terrence Howard ever sees this, that would be amazing. I have some physics principles, I think, that would really support his arguments. So we'll go through them, try and check them off. This is from July 7th, 2023. I'm not going to go through the whole thing, but I'll just give a basic understanding. So this is, again, my theory I've been working on for 2+ years now. And before that, actually, it's really why I started creating content at all. Scalar theory of the multiverse, a size-dependent emergent property approach. And I couldn't have done it without ChatGPT-4. And ChatGPT-4 has gotten better and better. So the solution is refining as the AI gets smarter. And the ChatGPT-4 actually calls this fractal. So later on added that this was a fractal theory, as we see here, fractal universe. So this paper presents a novel approach to understanding the universe from the lens of scalar theory, positing the existence of different dimensions defined by their scale. Each scale or dimension is proposed to possess distinct, yet subtly different physical properties arising as emergent phenomenon akin to the varying frequency of musical notes. This theory reframes the multiverse as different scales of existence within our fractal universe, each with unique dimensional properties. This is basically the same thing Howard is saying, right? Fractal universe. Okay, I argue gravity is an electromagnetic force, or it's some relation specifically to the electric and magnetic side of light. And then I argue that everything is just light. And that is basically what Howard is arguing. There's no particle theory of physics. He argues for the ether. And actually, Weinstein says your arguments on ether could be correct as well. So yeah, they just line up amazingly well. I'm not going to freak out or anything. I just want to explain it in a calm manner, not break any guitars, etc. Okay, so the scalar theory of the multiverse challenges the conventional understanding of physical laws, proposing that these laws operate differently at various scales. Okay, this is why you get different phenomena. That's why you get a Saturn shape with those hexagons, is because at that scale, you're going to have different properties than down at the microscopic scale or at our scale. This theory posits that each scale represents a distinct dimension with subtly different physical laws emerging due to the inherent properties of that scale. I also argue that it repeats. This perspective reframes the concept of the multiverse not as a collection of separate parallel universes, but as different scales of existence within our universe. So this is how you could have fifth dimensional space. When David Grush says, well, maybe the aliens are right here, but just in a different dimension, is actually they could be in a larger or smaller dimension, but of the same universe. This paper aims to inspire new avenues of research and exploration of our fantastic universe. I hope so, and I hope Howard would ever see this. That would be amazing. At the end of the Eric Weinstein Howard interview, they talk a lot about music. Okay, why is that? Because music, just like light, works on frequencies and wavelengths. It's a logarithmic scale. The main thing that filled in for me for Howard is why are we not seeing a logarithmic scale in the scalar dimensions? I'll go through that in a second. The scalar fractal theory of the universe likened to musical structures is a speculative idea suggesting repeating patterns and designs akin to how we observe in music. This is because you have repeating patterns in music, right, at different octaves, based on the doubling of frequencies. This theory posits a universe that could be understood in terms of scales, keys, and tones, each corresponding to different scales of size or energy in the physical world, based on whatever fractal dimension you're at that point. The idea draws on self-similarity in fractal structures, patterns that repeat at various scales. In music, we see this in the octave arrangement of a scale. Each octave is a repeat of the same set of intervals, but at a higher frequency. Remember, I wrote this a year ago, July 2023. The theory suggests that the universe, too, might exhibit such repeating structures across different scales. Okay, and how do we find that with ChatGPT, using ChatGPT, methods and approach? The foundation of this theory lies in the observation of similar emergent properties recurring at scales differing by a factor of 10 to the 21, analogous to repeating octaves in music. Using ChatGPT-4's amazing breadth of information and data analytics, we established clear, big-picture charts of the observable universe from the smallest conceivable object to the entire universe. By examining various scales from the Planck length to the observable universe, we can identify similarities that hint at a universal principle of scalar organization. So basically, what are patterns? Are we seeing fractal patterns re-emerge? Results. The results of our analysis, as presented in the integrated table below, reveal intriguing patterns of similarity in structure and organization across multiple scales of the universe. These patterns occur approximately every 10 to the 21 meters, repeating after every 7 steps, akin to the 7 distinct notes in a musical scale before reaching the next octave. Okay, this is where he kind of filled in the pattern for me. Why is it 10 to the 21 meters? And is it really based on a musical scale? I think not really, but a musical scale is logarithmic. I'll explain it here in a second. That's really what cleared it up for me. So initially, this table was incorrect. After I posted it, again, ChatGPT-4 does make mistakes. This all needs to be checked. And again, this is speculative theory, obviously. But if we look here now, okay, so what Howard's theory really cleared up for me is, why does this go up in sizes of 1,000? Okay, because it seems like it should be a doubling of frequencies. Okay, so how did I initially get to this? Is I started with the electromagnetic spectrum, okay? And what you see is your frequencies here is a logarithmic scale, because you are actually doubling frequencies as you step up in a musical scale, for instance. So frequencies work like music is a logarithmic scale. And that's what they're talking about when they go into all these discussions, Eric Weinstein and Terrence Howard, when they're talking about the 12th root and when they're talking about equal temperament. That's what they're talking about, is that these are actually scaling as a logarithmic scale. Okay, so like this is your note, C, right? 32 hertz, the first octave. So if we double the frequency now, you get to a second octave. So in here is all the notes we're ever going to hear. And you can divide it up however you want, right? In Western music, we divide it up into 12 semitones, right? A sharp, B, C, C sharp, D, D sharp, E, F, right? There's no E sharp, G, G sharp. Okay, so you divide it up actually into 12ths. And that's where you get the 12th root of 2, right? It's going to give you your difference in between these octaves, okay? And so why does that make sense? Is because as we double again, right, from second to third octave is not 32 again, right? Now it's 65, okay? So your difference between a B and a C in this octave and your difference between B and a C in this octave is different. It's a different number of frequencies, okay? So the way you actually break out the difference between a B and a C is you multiply it by 1.056. You have to multiply it. You can't add frequencies. For the same reason here, okay, if I go between a butterfly and a needlepoint, I'm going to have this many waves, right? You see. But now if I go between a needlepoint and a protozoan, I'm going to have double the waves in between. And actually, as it's going along, you're going to get more waves. So the beginning of that is here, and the end of that octave is much closer together. It's a logarithmic scale. So what does that mean? In order to actually break out 12 sections for Western music or 26 sections for Eastern music, or if you just want to divide it in half, okay, how do you divide it in half? If it's doubling, the square root of 2, and that would give you exactly half. And that's where he says, what is so critical about the square root of 2? If we go 2 here, right, and then do the square root, we get 1.414. So if I go back here now, if I take half of this between the first octave of C and the second octave of C, what is that, 32? It's not going to be 16, right? But as an approximation, if I want to break this out into 2 equal halves, I have to multiply the first half of this frequency times the second half to determine how much is in there. The square root of 2, what's about half? I don't know. I'm going to guess around 45. So let's multiply it times around 45. Okay, is going to get me. So it's a little off, right? That's into 2. If I break it up into halves. Okay, so ChatGPT 4, I think it explained it better. Here we go. Why multiplication? Logarithmic nature of hearing. So human perception of pitch is logarithmic, meaning we perceive equal ratios of frequencies as equal steps in pitch. So we perceive relationships, right, between frequencies, not actual 100 hertz step outs. For example, we perceive the interval between 100 hertz and 200 hertz, a doubling, as the same as the interval between 200 hertz and 400 hertz, another doubling. So it's not the same as 100 hertz plus 200 hertz. You can't just add them together. Why? Because the scale is logarithmic. And I think this comes back to when he talks about 1 times 1 equals 2. Okay, equal ratios for equal steps. So to divide an octave, which is a doubling of frequency, into equal perceptual steps, each step must be an equal ratio of the previous step. So you want them all to be the same size, right? But the only way they're the same size is if you multiply them. So the ratio for each semitone step in the 12-tone equal temperament, so when we divide it out, right, that octave, doubling a frequency by 12, you get the 12th root of 2, right? Because it's a doubling, and I want to divide it up into 12 steps. So I could divide it up into 25 steps. I'm going to get a different multiplicative factor, right? But if we want to divide it out into 12, like Western music, this is what we do. Doubling frequency for octaves. An octave corresponds to a doubling of frequency. So if you started a frequency F, the next octave is 2F, 12 equal steps. To divide this octave into 12 equal steps, we need each step to be the same multiplicative factor, r, right? So that's how you have to divide it up. Okay, and that's how we get 1.05946, right? Is because we have 12 steps. So we're doubling. So we do the 12th root of the double. 12th root of 2 is equal to 1.05946. Like I just showed, if you use the square root of 2, you want to divide it just into 2 equal partitions, you would use that number, which was like 1.45 that I showed earlier. Okay, so that's what they're talking about. Okay, and then just to finish his 1 times 1 equals 2 argument. So if we think of a logarithmic scale and we want to break it up into equal parts, we use multiplication, right? We use multiplication. But now if you're thinking linear terms, right? So let's say between 1 and 10 on a ruler, I want to break it up into 10 equal segments. Now we use addition. Does that make sense? It's not a logarithmic scale. This is a linear scale. So a logarithmic scale, we used multiplication as like the derivative, right, to break it up into parts. Otherwise, I don't understand what he's talking about with 1 times 1 equals 2. But anyway, we continue. Okay, so that was a long digression to basically say is when I tried to look at the universe through ChatGPT of a doubling of frequencies, it did not work. Okay, there weren't any noticeable patterns that we could find. Okay, but if you look at the universe in terms of step changes of 1,000, 3 zeros, then it found a lot of patterns. So there are form and function similarities. For instance, elementary particles here, quarks and electrons, I labeled just as an F. Now, if we go further, that would be cells. Okay, so your basic cells could be argued as the basis for the next octave, the next scale, which would form into humans. If we go further to an F, you're looking at distance from Earth to Sun, basically the size of stars. So if you're looking at stars now, stars could argue they're not the same. Obviously, they're insane differences in scale, but in terms of form and function, they could be the basis of the next octave, right? And form into things like solar system and galaxies here, right? Galaxy could be the center of the next octave up, could play a certain function as an A. And if we come back here, what is another A is atomic nuclei, the center. Humans also form the center. You know, if we look at DNA particles, molecules, where information is kept, right, for the next octave, next scalar size, you go down to D and E, right? Nations, small countries, up to planets, at least in form and function, look similar and have similar function with the next scale of the fractal, right? And what's amazing is what cleared up for me, what Terrence Howard cleared up for me is that it jumps in 3, 6, 9, right? If you think about it, that's 3 dimensions. So if it gets 10 times larger, it's getting 10 times larger in the 3 dimensions.
There's it goes. Just let it play. You'll see 1, 2, 3. And we know this is magnetism because it's expanding in the center. Now you'll see.
Okay, sorry, I'll stop it there. But if you notice there, 1, 2, 3. So this is, you're basically Lynchpin right here. From what I understand, is that your initial starting geometric shape, and then this will fit in scale fractal into what I explained there, much larger and maybe even smaller scales.
See 6 of these bonds. And those colors going across there is basically the periodic table. 5, 6, yep. And then the last one comes in, and now you have your 9. And this is magnetism, like I said, magnetism that expands at the center. So you have your 3, 6, 9, and it's back to that same fractal again. So now what you do, if you will do me a favor.
So when Tesla said that, what did he mean?
He was talking about these numbers, this interaction of these 3, 6, and 9.
So that's what really cleared up for me was the logarithmic scale. It's not based off a log scale. It's based off of this. Why? Because the fractal is formed. So I'd never used Python before. I never coded anything. I asked ChatGPT 4 to code me what it thought was the linchpin structure. This is the first thing it came out with, right? And then I basically said, no, that doesn't look correct, but I think it is. This is a tetrahedron. 1, 2, and I think it's going to go into the floor. Getting better. And I said, okay, so I think 1, 2, 3. And then this is the basis of what I understand is the linchpin. But it's those 3, that initial starting point is the start of the fractal. And then it's just going to expand out. So amazing stuff. So I have several other notes and points. I don't want to make this video go too long, so I'll just finish here on the conclusion. The logarithmic scale in our study is similar to the one used in music theory to understand musical notes. The octave in music, which is a frequency doubling, is analogous to our analysis of repeating structures across the universe every 10 to the 21 meters. It happens every 10 to the 21 meters and not related to frequency doubling because of the linchpin that Eric Weinstein says could most likely be correct. In Western music theory, a scale is divided into 7 distinct notes, actually 12 semitones, after which the scale repeats in the next higher or lower octave. Each letter in an octave represents a specific frequency, with the frequency of each note approximately 1.05946, the 12th root of 2, because we divide it up into 12 steps, times the frequency of the previous message. This relationship between notes represents a logarithmic progression. In our scale of the universe, we similarly observed a repeating pattern of structures every 10 to the 21 meters, the universe's octave. Moreover, there appear to be 7 distinct steps within each octave akin to the 7 notes in a musical scale. So again, this is the Western musical scale, and that could be incorrect. I'd love to see that refined through his actual physics engine. The correlation is not just a numerical coincidence, but could indicate a deep-seated fractal characteristic of our universe. Yes, and this is the fractal characteristic of the universe that could be proven correct by Howard's physics engine using his linchpin. Can he predict solar systems? Can he predict galactic structures? Can he predict the actual shape of the observable universe using this simple physics engine? That would be amazing. It could prove his theory and maybe this one. A fractal is a mathematical object which is self-similar at different scales. There you go. If you zoom in or out of the fractal, you will see similar patterns. Given the observed repeating patterns of organization and structure at the different scales of the universe, it is plausible to theorize that the universe might have a fractal nature. However, while our observations suggest this possibility, a much more comprehensive study and empirical evidence would be needed to establish the fractal nature of the universe.
Like I've said a number of times, you show me a real straight line in nature. If everything in the universe, everything is expressed in motion, all motion expressed in waves, all waves were curved. Every action has an equal and opposite reaction. So the greater the action, the greater the reaction. The greater the reaction, the greater the resistance. The greater the resistance, the greater the curvature. Because the universe is based off of equanimity, which Einstein left out in his theory of relativity, the balancing side of the gravity was caused by electric force. Electricity is always seeking a higher pressure condition. It spins northeast, is trying to get to the center of an area, the center of a cone. But the next electric wave is coming, so it gets pushed out, and as it's pushed out, it gets to the vortices. And that's some on those pieces, those vortices. Now, instead of it spinning northeasterly, centripetally, it's forced to spin centrifugally, and it spins southwesternly. And it expands itself out, it decays, it keeps decaying until you get 4 magnetic waves that hit each other at 120-degree angles. At that point, they reconvert back into the electric field, and then they make their way back to their source again, whether it's the star, whatever star it came into. What happens when we get older? We expand at our equator, right? We get shorter at the top. Why? Because the electric force is pushing in and condensing, and the magnetism expands out at the equator. The electron field, the electrons, that's just discharged electricity, devitalized electricity, coming from the sun, coming from the earth. It's the waste. product from it. But it hits our magnetic field, and then it gets pulled right back in and gets compressed again, and now it becomes electricity for the Earth, and then it pushes itself right back out again at the equator. The equator is 5 miles wider than the poles. Electricity, Einstein left that out of his equation because he coupled electricity and magnetism together and didn't realize that electricity was the equal and opposite of magnetism. Electricity being the contractive field. You breathe in, that's a contractive thing. You breathe out, that's a magnetic thing, a radiative thing. But they use the term magnet as an attractor. But to magnify something means to what? Make it larger, increase the space. That's the work of radiation. That's what Walter Russell was talking about all those years. That's the work of radiation. It's the electricity between the things that pull them together. The Coulomb force that supposedly opposites attract and push each other away. If that was true, then hot air and cold air would seek each other out. The reason two magnets seem like the North Pole is attracted to the South Pole, because if you had two rivers or two hoses with water coming out of them, and you pointed them at each other, what are they going to do? They're going to be pushing against each other. But they align to where the male enters the female and is able to come out. So they've been fooled by their senses. They've been fooled by their eyes and have missed the whole picture of it.
Terrence Howard makes the argument that gravity is really electricity, or the electric field pulling, and magnetism is the opposite, so the equal and opposite reaction. So everything has an equal and opposite reaction. And so when you have a pulling effect due to the electric field, then you're going to have an equal and opposite magnetic effect that forces it away. But when you get to a high enough pressure, mentions pressure a few times in there, then you're actually going to curve space enough. And I would say that would be to the Schwarzschild metric. Schwarzschild metric is the mass and radius. Really, you need the amount of stuff in a little amount of volume to actually bend light. So that's where the event horizon is on a black hole, is the Schwarzschild metric, the radius. You can calculate the radius of the event horizon just based on the mass. And really that's telling you a density, isn't it? Mass per volume. And that's really what Einstein's equations all did. Let's look at this famous equation. E equals mc squared. Okay, but when Einstein actually made it, I think when he originally wrote it, he wrote m equals E over c squared. So this is what Einstein actually wrote. So mass is equal to energy over c squared. And c is just the distance light travels in an arbitrary amount of time, right? We declared it the second, because this is in meters per second. But you could say it's anything like tetrasecond or something, but we define c. This is how far light's going to travel within this amount of time, right? So that's a distance. So this is energy over a distance times a distance. What does that look like? It looks like a pressure, doesn't it? So pressure is the force applied perpendicular to the surface of an object per unit area over which that force is distributed, right? You could argue or make an argument that matter is amount of energy. In this case, I'm going to say photon energy per a unit of area. In this case, it's a very large unit of area. That's why there's so much energy inside of matter. I think because it's just a huge amount of light energy, photon energy. And when he mentions pressure there, check this out. This is radiation pressure, also known as light pressure. So light pressure, radiation pressure, is mechanical pressure exerted upon a surface due to the exchange of momentum between the object and the electromagnetic field. Look at that. That's what light pressure is, exchanging momentum between light and an object, right? Light is massless, isn't it? So how can it actually transmit momentum? So this includes the momentum of light or electromagnetic radiation of any wavelength that is absorbed. And what's even more interesting here, or reflected. And when it's reflected, the momentum doubles. This is amazing to me. Or otherwise emitted, e.g. blackbody radiation, by matter on any scale, from macroscopic objects to dust particles to gas molecules. So radiation pressure, light, how light transfers momentum. Amazing. And it goes from all scales, right? Look at that. Matter on any scale. Sounds like a scalar invariant kind of pressure, right? Where's this pressure coming from? It's coming from the force of light. I feel like we're in Star Wars, the force of light. The radiation pressure forces are the bedrock of laser technology and the branches of science that rely heavily on lasers and other optical technologies. If we talk about radiation pressure in terms of photons, this is where we get the formula. Momentum is equal to Planck's constant over the wavelength. Isn't that amazing? That's equal to your energy of P over C. So look at this. If we just decrease the wavelength, right, increase the frequency, what are we doing now? We're going to increase the momentum. So this is why your gamma rays, your high-end, super small waveforms, right? So when nuclear radiation, when you have very super high frequency light, this is why it goes right through you, just punches through your body, is because it has a ton of momentum. It has a ton of energy just by lowering the wavelength, increasing the frequency. And they've known about it for many years, since we've basically been seeing comets. I believe Kepler actually said, is there like a radiation pressure, right? So it's actually transferring momentum. That could be the force, the electric force, basically is what Terrence Howard's talking about. And according to the energy mass equivalence of Einstein, once that energy per unit of area gets to a high enough number, it's going to curve, bend space, probably to something related to a Schwarzschild metric, some sort of distance like that. And it's going to, I believe, create mass, create matter. Okay, and as the last point, I'm going to mention Dirac's large number hypothesis. And I think this could link the proton, or the structure that Howard is talking about, his base unit, maybe the Lynchpin, and relate it to the entire observable universe. And this is how you can find gravity down at the lower levels. So the problem is the gravitational force for large objects is the dominant factor, right? That's the dominant effect. But when you go down to the quantum world, they can't find gravity, okay? But they do use this Coulomb's law, basically. So this is the force of attraction at very small levels. They call it the electrostatic force. And this is the force of attraction at very large levels, right? And so far, they can't find gravity at the quantum world. And if you try and basically scale our rules down, what you find is there's a huge disparity, okay? So here is the force of gravity, newtons, okay? And newtons is in kilograms times meter per second squared. Okay, and this comes from Newton. Force equals ma, mass times acceleration. That's Newton's second law, states that the force acting on an object equal to the mass of the object multiplied by its acceleration. So F equals ma. That was a great one. E equals mc squared. That was a great one. That's a great theory. Simple, knocks everything down to its basic constituents, and then we'll see what the theory Eric Weinstein says is our current best model. We'll look at that in a second. But here you have the gravitational force is this, times 10 to the minus 47, right? Well, if you measure based on charges, not really masses, right? Because photons don't have any mass. Somehow they can transmit momentum, right? They can exchange momentum, but they have no mass. So what they use is charge. Okay, so they do the charge here, and what you find is when you calculate this number, it's to the minus 8. So it's way bigger than the force of gravity, right? How much bigger? 10 to the 39 times bigger. So this is Dirac's large number hypothesis. This is a huge number, 10 to the 39. So that's his 10 to the 39 number, but there's other interesting relationships, right? The ratio of electrostatic to gravitational forces is roughly the same as the ratio of the age of the universe in seconds to the classical electron radius. So basically linking the classical electron radius to the age and thus size of the universe is roughly equivalent. So if you put the large scale G, right, gravity on the top, and divide it by the electrostatic, the small scale on the bottom, you get 10 to the 39 for ratios of forces. If you take the size of the greater universe, essentially the age, the size, and put it over classical electron radius around the size of a proton, okay, so the size of the universe divided by the basic rough size of a proton, you get around the same ratio, 10 to the 40, approximately the same magnitude, very close. The fact that these numbers are so huge is amazing. That's 39 zeros, 40 zeros. The fact that they're so huge and almost equivalent is also amazing. So Dirac basically says that there's some underlying relationship. Okay, so even better is what you can do then is observe the number of protons or baryons in the observable universe. And that is an extremely large number as well. And that is 10 to the 79. Okay, even larger number. But what is 10 to the 79? It's basically 10 to the 39 squared, or in between 10 to the 39 and 10 to the 40. You square it. And what have we been talking about? C squared. There's a squared number in there, like an area. He also mentioned you have an electric and magnetic field. So chances are we're only measuring 1/2. I'm arguing we're only measuring the actual electric, not even measuring the magnetic. So if that's two sides of it, you square it, now you get to 10 to the 79. So one of the key observations is the ratio of the electrostatic force to the gravitational force between a proton and an electron, which is approximately 10 to the 39. If this ratio is squared, it gives 10 to the 78, which is close to the estimated number of protons in the universe. So that is another interesting mystery of physics that Howard could apply to his theory, right? The radiation pressure is going to get you to a certain number. And really what he needs to answer is the fine structure constant. The fine structure constant, denoted by the Greek letter, I don't even know, alpha, is a fundamental physical constant characterizing the strength of the electromagnetic interaction between elementary charged particles. So it's that famous number, right? 1/137. No one knows where it comes from. If his model, if Howard's model can answer where it comes from, that would be amazing. And I think it may, right? Because here you have the fine structure constant is dimensionless. It is given by this formula. So E is the elementary charge, the charge of an electron. So this is measured, right? We measured this on the top squared. E naught is the vacuum permittivity. So this is measured. This is the permittivity of space, right? How fast light goes through it. H bar is the reduced Planck's constant. Planck's constant is E equals HF, energy equals Planck's constant times the frequency. That was one of Einstein's favorite equations. And that is where the actual orbitals happen, right? Planck's constant comes out of thin air, really measured. And that constant times the frequency is going to tell you when that photon is going to execute, like the photon electric effect, when an electron is going to pop off. Because it doesn't pop off before that, doesn't pop off in between, it's discrete. And that's where it comes from. How do you know where these discrete levels are? It comes from Planck's constant. And all of that is wrapped into the fine structure constant. So C is the speed of light in a vacuum, right? So that's the fine structure constant. So it's significant because the fine structure constant quantifies the strength of the electromagnetic force that acts between charged particles, such as electrons and protons. It appears in the equations governing the interactions of these particles. So if you can show that this is the same force equivalent as gravity, then now you have unified physics. And that comes from the fine structure constant. Okay, I'll leave you with one final thought because it's just so mind-blowing, I think. And this would be great to send to Terrence Howard. Howard argues that there's no straight lines in the universe. Nothing is straight. That's one of his key tenets. And he gets an argument with Eric Weinstein, basically saying that there's nothing straight in our universe. It's all based on Cartesian coordinates, right? Straight lines. And here's a principle that I think he can use to make that argument. This is called the Huygens-Fresnel principle, okay? I think it's shorthand called the Huygens principle, and Einstein used this, states that every point on a wavefront is itself the source of spherical wavelets, and the secondary wavelets emanating from different points mutually interfere. So what does this mean is when light refracts, right, it's really going different speeds in different mediums, and that's what Howard said, yes? But if you, even with a straight, what we would call a flat planar wave, right, as it hits here, it isn't refracted straight. It's actually refracted as, I would argue, an infinite number, or maybe the frequency of the light, of wave spheres. This is how you can have that crazy polarization of light, right? When you twist light, like on an LED screen, this is how light polarizes, right? When you have a polarizer, how does the light bend? And then how do you make the light come back, right? This could explain all your light polarization, crazy things that happen. Because I can put another polarizer after light has been effectively polarized and we'll spin it back the other direction. Now, how does that happen if light is really just moving in a straight line? Well, chances are light is not moving in a straight line. As Howard is arguing, right? Everything is curved. And if you look here, that's really what the wavefronts look like, is actually little small circle, okay? Everything is actually a circle. Nothing is flat. So even here, it's really just a tiny little circle, tiny little circle, tiny little circle. And when it lines up, it creates a flat planar wave when they happen to all match up. So light is actually moving as an infinite number of little tiny field circles. You know, it's a pulse essentially. This explains your diffraction pattern because it's actually a little pulse there. Okay, and this could explain double slit. Why are we seeing double slit experiments? Is it because everything is linked? As Howard says, is that we're all actually linked. You can't have stillness on any one part of the system, or the whole system would have to be completely still. So I just think Terrence Howard should definitely look into Huygens' principle. I think it would further his argument that there are no straight lines. Okay, it's actually not straight. Everything is circular. Please confirm from light. And then the final point I want to bring up is dislocations. Okay, he mentions the ether, and Eric Weinstein says, well, that's a great point. Actually, could have ether, actually could be a thing, right? And this would say that there's only electric and magnetic fields. That's all there is. All there is basically light, and it's going through some sort of matrix, like an ether. So how do dislocations actually happen? When you break a metal, okay, what actually happens is it actually changes, dislocates, right? What you're going to see is this is going to move over. Boom, you see that? It moved, jink, it jinked over this bond essentially. Okay, this bond jinked over. What's amazing is that if you actually do the math and calculate how fast this dislocation is moving, it moves at the speed of light. It moves at the speed of light. It's almost like it's moving through the ether. So I think Terrence Howard should also look into dislocations, specifically when he's considering the ether and how to prove the ether. You know, this is how dislocations move. It's amazing. So I would recommend check that out. And hopefully I'll bring it forward in further videos. I don't want to make this too long. But long story short, I think we can verify a scalar fractal theory of the universe as Howard and I are proposing. And I think he has the math to actually make it happen if he can prove it with that physics engine. And it falls in perfect line with the light-love theory, basically that there is only light. It has an electric and a magnetic component, which are really opposite each other, counteract each other, kind of spinning together, if you will. Amazing stuff. Hope you enjoyed it. Thank you for watching. Please hit the like button. It really helps, and it's free. Consider subscribing to get future notifications of when I release videos. And you might like this video recommended by YouTube just for you. If you want to support the channel, join these great people over here. Get exclusive bonus content, then click this button here, patreon.com/Chris Lehto, or become a YouTube member. If you want to continue the discussion, go to UAP Society Discord. Links are all in the description. Have a great rest of your day. Peace.